Right, today we're going to look at solving quadratic inequalities the cheap way. Let's go! So here's an example of a quadratic inequality. Well, here's an example of two quadratic inequalities. All it means is we've got an inequality sign, so in this case greater than 0, and we've got a quadratic, something that involves x squared. And I'm going to talk you through a quick little three-step method that will enable you to solve these. First thing, we need to rearrange it to x squared on the left hand side and then the 0 on the other hand side. That's already been done, so there's nothing that needs changing there. Step 2, we need to factorize it into brackets. Okay, so this is a fairly simple factorizing. Again, look back at my video on factorizing if you forgot it. We need to multiply to 10 and add to 7, so those numbers are 2 and 5. So that's what that factorizes to. I'm going to keep the greater than 0 there because it should still be there. Secondly, we need to solve to find the key values. So that's where we set each of these brackets equal to 0 and we solve them. In this case, we can use the little shortcut that it's just going to be the negative of those two brackets. So our two key values are -2 and -5. Cool. So this is the extra step though, because those first two are just the same as solving a quadratic equation. If it's a greater than symbol, then we want either side of the values, and if it's a less than symbol, we want to be between the values. So we're going to draw ourselves a little number line. The numbers that we've got here are -5 and -2, and we've got a greater than symbol, so we want to be either side. So we want these numbers over here and these numbers over here. We then just need to sort of write that down in inequality terminology, which would be saying so x is less than -5 or x is greater than -2, and that's it. So that's that last extra step. So exactly the same as a quadratic equation, a little bit of inequalities at the end. So let's do that with the other one. Firstly, we need to rearrange it, already been done. Factorize it into brackets. So times to -18 adds to -3. That's going to be -6 and +3. And again, remember the symbol. Solve to find the key values. So change the signs. Our values are 6 and -3. And then put them on a number line. So we've got -3 and 6. And we have a less than symbol this time. So we want to be between the values. So that is the region that we want. So we would write that like this. -3 is less than x is less than 6. So if it's either side, you end up with 2 answers. If it's in between, you end up with like one nested answer. Okay. Worth pointing out, this is not how I'd recommend doing these at A level. There is a much more understanding based approach where you sketch out graphs and you consider their positions within the graphs. But for GCSE, this will do just fine, and it's a lot quicker. So let's just have a look at a couple of different spanners that we could throw into the work, and particularly I want to point to that thing written at the bottom there, that your signs should match the question. On our first two there, we used less than and greater than symbols, because that was actually what was in the question. Here, we've actually got a less than or equal to symbol, so our answer is going to have an or equal to it as well. Let's see how that works. So firstly, rearrange, done. Factorize this into brackets. So we need to add to 1, because we've just got 1x in the middle, and times to -12, that's 4, and -3. Don't forget your symbol. Solve to find the key values. So the key values there are -4 and 3. And then number line, we've got -4 and 3, and we have this symbol. We have a less than equal to, same sort of thing. We want to be in between those two. And this is the point where we should match the question. So we're actually going to write -4 less than or equal to x less than equal to 3. So that's the only difference there. We've got an or equal to. What about the second one? Rearrange. We do actually need to rearrange this. So we want to have x squared on the left hand side, which it is, but we want to have 0 on the right hand side, which it's not. So we're going to need to subtract 7x across there and end up here. Then we can factorize it. And it's the same thing with solving quadratics, isn't it? You need one side equal to 0, but factorizing that, times is to -18, adds to -7, that's going to be -9 and +2. And then key values there are obviously going to be 9 and -2. Sketch that down, so we've got -2 and 9. And then let's look at our symbol. Our symbol is a greater than this time, so we want to be either side of those values. So how would we write that down? We would say x is less than minus 2, or x is greater than 9. So again, we match the fact that there is no equal to in the original question, so there's no equal to in our answer as well. Cool. Let's have a look at a couple more possible problems. So this is two things that are meant to make your life easier actually, but people tend to get confused by. Sometimes they'll give you a question where they've already done the factorizing, and what people will do is they will just expand those brackets because that's what you do when you see brackets, but you don't need to. All this is a question where step 1's been done and step 2's been done as well. Already been factorized, so we just need to solve to find the key values. Now this is actually one where it's not just change the sign. I mean, we can with the plus 7, but the 2x minus 3, that's the one where we have to like rearrange this. So we'd have to add 3, divide by 2. So we'd end up with 2x is 3, so x is 1.5. Don't forget, if it's x plus 7, yeah, we can just change the sign. If it's 2x, you need to think about what would actually make that bracket 0. Then we can go to the last step. So draw this out, we've got 1.5 and we've got minus 7. We've got a greater than symbol, so we're going to be either side of these values. We just need to write this down, and we have a or equal to in our question, so we should have an or equal to in our answer. So x is less than or equal to minus 7, or x is greater than or equal to 1.5. Cool. What about this second one? What's the problem here? Well, obviously we've got the first thing that we need to subtract the 15x across, but I don't think that's going to be the issue. It's that people forget that you can factorize something like this by just taking out a factor of x. I'm sure I've mentioned that in the factorizing, and I think in the simultaneous equations as well. But it's as simple as that. You don't need to think about adds to this, times this to this, just take out a factor of x. Solve to find the key values. Don't forget that x on its own gives you an x equals 0. And also we've got x is 15. We have a greater than symbol, so we are going to be either side of the variables. So here's 0, here's 15, either side, no or equal to in the question, so x is less than 0 or x is greater than 15. Okay, one more set of weird questions to look at then. This one on the left here is another classic. I know a big tendency here is to just square root both sides because you've got x squared and you've got 49. You've got to bear in mind that I'll have positives and negatives and won't necessarily give you the inequalities you want. There is a general rule with inequalities that you can't square root and maintain it. Squares in general don't work. Think about this. We've got minus 3 is definitely less than 2. It's more negative. But if I square both sides, I get 9 and 4. And 9 isn't less than 4, so the symbol has to change around. So I try and avoid squaring and square rooting completely when I'm doing inequalities. Anyway, so we need to rearrange this first. So we're going to subtract the 49. That's all right. We're going to need to factorize this into brackets. This is actually a difference of two squares. This is an x plus and an x minus the same thing. In this case, 7, because that's the square root of 49. Find the key values then are minus 7 and 7. Let's draw it out. And then our symbol is a less than, so we want to be between the values. So we're just going to go like that. Minus 7, less than x, less than 7. We're out for the second one. So we're going to need to rearrange it again. We're going to need to subtract 27x. We're going to need to add 18, and we've got a greater than 0. And just bear in mind that if you've got more than 1x squared, you're going to have to use either a longer factorizing method or the MAM sort of shortcut to do it. I think in this case, let's use MAM because it's always good to sort of keep that in practice. We want to multiply to 4 times 18, which is 72, and we want to add to minus 27. And what are the numbers that do that? So 72, we could have 2 36s. No, we could have 3 24s. Yeah, that looks like it's going to work. So we'll have minus 3 and minus 24 as our numbers. So we're going to need to split this up into 4x squared, minus 24x, minus 3x, plus 18. So factorize each half, 4x lots of x minus 6, minus 3 lots of x minus 6, and then bring it all together, 4x minus 3, and x minus 6. I know I say it's a long method, but actually if you just get on with it, it doesn't take that long. Anyway, we need to solve to find our key values, so we're obviously going to get x equals 6 from that bracket on the right. And the other one, we're going to get 4x equals 3, so x is 0.75. You could say 3/4 as well, but I find inequalities are generally easier to work with decimals, particularly if you're going to have to draw them on a number line. So we've got 0.75 and we've got 6. We've got a greater than symbol, so we need to be either side of these values. So we need to be over here, and then just write down our answer. X is less than 0.75, or x is greater than 6. And yeah, that's it. This is considered a very high grade topic at GCSE. We are talking grade 8 at the minimum. But this little cheap shortcut really does take out most of the harm of it. Have fun.